Three factors determine the resistance to blood flow in a vessel: diameter, or radius, length, and the viscosity, or thickness of the blood. Contraction of vessel walls can result in a small change in diameter, but a large change in resistance. This relationship is known as Poiseuille's law. This equation shows how voltage, V, equals the current, I, multiplied by resistance, R. Ohm's law can be related to fluid flow, where the voltage difference is the pressure gradient, P, resistance is the resistance to flow, R, from the vessel, and the current is the blood flow, F. Doppler frequency, or Doppler shift, is the change in the frequency of sound waves that occur as they are reflected off a moving object. A real-life example is how you hear a siren as an ambulance is driving towards you, and how the sound changes as the vehicle travels past and away from you. This is how the principle of color Doppler works when studying blood flow and the movement of red blood cells. To obtain the best Doppler images and detect the largest Doppler shift using ultrasound, the transducer must be placed at an angle of 0 degrees to the vessel of interest. However, due to practical considerations, an angle of 60 degrees is used. Color Doppler can distinguish when blood is flowing towards and away from the transducer. When blood is moving towards the transducer, it is termed a positive Doppler shift, and is represented as a red flow of blood on screen. A negative Doppler shift, where blood cells are moving away from the transducer, is represented as blue on screen. Different types of color Doppler also exist for use in cardiac and vascular ultrasound. Cardiac ultrasound primarily uses continuous wave Doppler. A continuous wave transducer is designed to be able to have one part of the transducer constantly producing a sound beam and the other part of the transducer constantly receiving the sound waves that are reflected back. Continuous wave transducers can also accurately determine the speed at which blood flows. Pulsed wave Doppler is primarily used for the rest of the vascular system, as the round-trip effect enables a greater accuracy about location rather than just blood speed. Whereas color Doppler is used to assess patency and blood flow, spectral Doppler, or spectral analysis, is used to quantify the amount of blood flow and resistance. Each part of the systolic peak represents the range of different blood velocities at a given time. The highest point on the peak indicates the maximum velocity. Most machines now automatically calculate velocity, resistance, and pulsatility. Power Doppler is more sensitive than conventional color Doppler for the study of small vessels which have low blood speeds, as it overlays Doppler information on a grayscale image and just shows the energy within vessels. It can also be used when unsatisfactory color Doppler images are obtained, as it is less reliant on the correct angle of incidence of the transducer to detect a Doppler shift.